on the topic of understanding the complexity of the videos that our students are interacting with. In this talk, we're going to learn about two interesting new measures for measuring whether or not complex videos make a difference. Is it a good thing or is it a bad thing? So here to tell us the answer to that question is Frans van der Sluis. Can you say your name so you get it right?
Well, in Dutch we say van der Sluis.
I would not have guessed that. No way. Thank you. Thank you for doing that.
Thank you for your attempt. Okay. Well, thank you. And indeed, the introduction was kind of correct. So I am going to talk to you about the influence of video complexity, but I'm not going to tell you whether it's good or bad. So I'm sorry for that already. And in general, I would say, even though this is a session on engagement, the paper and the talk I'm going to present to you is more about about a methodological message. So this might be dangerous, of course, just before lunch, but I hope you can manage. So I'm going to try to answer the question, how can we explain student behavior at scale? And in other words, what does it mean when we measure something, such as the amount of time our students spend watching MOOC videos? And complexity fits into that. So let me first walk you through a bit the background of this research. So the central proposition, I think we can all agree about this. We now have unprecedented scale in our learning, and with that, the opportunity, as has been mentioned already, the opportunity to measure and learn how our students learn. Yet, at the same time, it seems rather difficult to unambiguously assign meaning to all that we measure now. So if we measure clicks, if we measure the time students spend on a video, what does it all mean? And to give some examples, so right now, to the left you have a couple of things that are commonly measured. So the amount of clicks, the type of clicks, seek actions in the video, or simply the length of video. And with these very granular measurements, big predictions are made, like the learning outcomes or the dropouts within the video, within a course, or the level of engagement. And well, I can already give you one rule of thumb there. In general, the finding of this kind of predictions is that more clicks equals something better. So a very popular example of this is actually the GUO paper from 2014, which concluded that videos of 6 minutes are the 6 minutes lengths are the optimal in terms of engagement. And here, engagement refers to actually the time spent watching a video. And well, what we asked ourselves was, can we actually draw such conclusions from looking at how much time students spend watching a video? Does more time indeed signal a higher engagement? Or, as another popular notion says, does more time spent actually signals that the video was too difficult? It all's very intuitive, but is it correct? And to answer this, we studied what makes actually students have a higher dwelling time with educational videos. And we define dwelling time as the time spent on the task of watching a video, but then relative to the video length. So this is a percentage. And what we know about dwelling time from research on text is that actually, and this might surprise you, a higher engagement actually reduces the time spent. It seems that interested readers are better able of keeping focus and read at a faster pace. And the second might also surprise you, that difficulty can increase as well as decrease the time spent. And to explain how these two notions of interest and difficulty relate, I'm going to shortly introduce to you here the Wundt curve. This has been first thought of by Wilhelm Wundt more than a century ago, and half a century ago investigated thoroughly by Daniel Berlin. And great psychological work. Basically what it says is that the attractiveness of a stimuli depends on the novelty and complexity of the stimulus. And at first the more novel, more complex stimuli will drive up the attractiveness of it. So, as Berlin called it, the hedonic value. Yet only up to a certain point. After that point, the stimulus becomes too intense to cope with. And, for example, in the case of videos, this can simply be because they become incomprehensible. So this means that complexity can drive up as well as drive down interest. And when we relate this to dwelling time, that means we expect to find the exact opposite effect. So if interest indeed decreases dwelling time, then we expect dwelling time to actually increase with low as well as high complexity. Well, of course we wanted to verify these hypotheses and these theories, and for that we need to first tackle 3 challenges. And first is how to operationalize this thing called dwelling time. Second, how we analyze the complexity of a video. And third, which is actually the results, how actually the time spent reflects, is related to the video complexity. So let me first walk you through the first 2 methodological challenges here. The first is to actually derive a reliable estimator of student dwelling time from clickstream logs. And basically we've already seen from the first talk in the session that clickstream logs are kind of messy, dirty, chaotic, and there's lots of clicks, but you never know what happens actually in between those clicks. People might actually start drinking coffee and talking to their neighbors. So it's noisy data per definition. And luckily, well, since you don't know when somebody reached the end of a video, because people usually don't click there, that would make this thing impossible, but luckily Coursera has a nice automatic click event at the end of a video, which you could actually use to estimate whether people actually finished watching it. So our solution was to actually look at video sections, because we know when somebody reaches a in-video quiz or the end of a video. So the time between in-video quiz questions is what we call a video section here. And by looking at the seek actions and the play and pause actions within a section of a video, we could estimate the total time spent by a student within that section. And we did this estimation for almost 500,000 interaction sessions of students with our MOOCs. And while doing this, we differentiate between 2 different types of dwelling. And the one is, we call dwelling time, which includes the pause time. So this means we really don't know what happens when somebody presses pause. Somebody can go Googling, whatever. So we expect this data to have more variance, whereas the dwelling rate simply is a percentage of how much people, how much of the video somebody watched. So that was the first challenge. The second one is to get a valid estimator of how complex a video is. This might be even a more complicated challenge. And here the validity of such a model is of particular importance, because we want a model that actually predicts human behavior. So it needs to be related to what actually makes a video complicated for a student. And besides that, videos are actually rather complex in itself. They have both visual and auditory information, and they have a certain play and speech rate. So this is a bit too complicated to grasp fully. And what we did was we zoomed in on one particular aspect of the video, which were the video transcripts. And this, well, we felt that this was an okay approximation, because videos and in particular our MOOCs rely heavily on spoken words. So most of the learning content is actually covered in the spoken language of the video. And we actually analyzed our video transcripts of 101 videos using 8 features. And each of these features were derived from key findings in psycholinguistics to make sure they have a good foundation and validity in that sense. And each of the features, each of these findings actually reflect a cause of processing difficulty in language comprehension. So I'll give you some examples just to shortly show you what I'm talking about here. Just to give you an idea. So we have 4 types of features: traditional ones, priming ones, dependency locality theory, and lexical familiarity. And to give a bit more detail, well, you can take a look yourself. And actually, each of these features have are known to affect certain measures of how we humans read text, such as the recognition time we need to recognize a word, or the pupil size we have during reading. And of course, this just to give an impression. More details can be found in the paper. So what we did, we need a ground truth for our features. So what actually is the definition here of something simple and something complex? The features in themselves are not enough. We needed a ground truth. So we trained them on paragraphs from Wikipedia. And on the left, you see the results of that. The resulting model actually distinguishes here between the simple English Wikipedia, that's also a version of Wikipedia, and the right distribution there within the left graph shows the distribution of the normal English Wikipedia. And, well, the good news is our features, our model, managed to distinguish between the 2 different levels of Wikipedia. And in the graph on the right side, we applied it to actually model the complexity of our 101 transcripts. And you see that this also gives a nice distribution, which is actually very important to verify that we don't get any weird oddities here, since we're applying it to quite a different data set. And, well, I think it's very nice to see that our Coursera videos are actually, luckily, less complex than encyclopedia articles. I think that's good to know. So, that said, I'm now going to talk through, well, actually, I'm going to give you the results. So, comparing this to the complexity of our videos. Comparing the complexity of our videos to the dwelling time that our students have. And what do we see? Well, the following relation emerges. And what you see is, on the left graph, the effect of the complexity on the dwelling time, which includes the pauses, and on the right graph you see the effects on the dwelling rate, which excludes the pauses. And indeed, of course, including pauses, we have a higher variance. And in both, another small detail here, in both graphs we multiply the complexity of our transcripts by the number of words per second to account for changes in differences in speech rate. And this only includes those sessions, as I already told you, of students that actually finished watching a section, because otherwise we have no possibility of inferring how much time a person spent. So basically this effect for the right graph here explains 22% of the variance in dwelling rate, which I think is quite a substantial amount. And these effects are as expected. Both low and high levels of complexity increases the time spent here. And of course we can only presume why this is happening, because we haven't asked the student. But it is likely that it is because, well, if it's too easy, they have trouble to stay focused, and if it's too difficult, it creates troubles to understand the content. So, let's put these findings in perspective. Can we now assign meaning to this thing called dwelling time? And I'm going to discuss 3 conclusions, hopefully to answer this. And so the first one is actually that dwelling time, the idea might seem straightforward, how much time people spend, but its interpretation is actually not so straightforward. Because it seems that in and of itself, dwelling time is fairly hard to interpret. There are many variables that come together in explaining how much time people spend, of course. And this can be alleviated, luckily, by accounting for variables that are expected to influence it, such as the complexity of the content. As such, this study can be seen as a cautionary tale for deriving conclusions for even something relatively straightforward, such as how much time the students spent. The second conclusion is that by controlling for related variables, we can partly interpret the dwelling time now. So there is a little bit of hope. We have made a bit more of the picture visible here. So basically the face validity of our measure of video complexity, and with face validity I mean that the foundation in psycholinguistic findings makes it likely that it actually indeed predicts what we hoped it predict. This makes it that, well, we can conclude with a rather amount of certainty here that indeed the complexity affects the dwelling time. But of course there is the problem here that data-driven means data-dependent. It can be that our 101 videos had this relationship in there coincidentally, and that it would not be the same when we looked at all the videos in the world. But for the second part here, can we say anything about, well, the good or bad of complexity? Can we say anything about the actual engagement that students have? Well, no, we have no direct evidence for the relation to interest here. So the final and third conclusion here is that we need to look at broader pictures than just simple proxies of behavior to start learning about learning. And actually the key word here is triangulation. So this means that we need to combine different metrics that are theoretically related to that thing that we're measuring and trying to predict. So for this study we only partially filled this out. We had some objective properties of the content here, the complexity, and we had a behavioral proxy, the dwelling time. And actually theoretically within the framework we have something subjective which is interest, but we haven't filled in this picture with actual measurements. So, but this is important to actually have both sides here. The left side is what we like a lot, actually. The left side is what brings us the scalability, because the objective properties can be calculated and the behavioral proxies can be calculated for everything and everybody. And we still need the right side here, which is the theory and the subjective check to actually say how this relates to and what the implications are for something about our students and the learning process they experience. So I think this, well, keep this one in mind. We need both sides. And to reflect now finally on my initial slide about some common ideas about the influence of complexity. Can we say now that more time is a proxy of difficulty? Well, yes, we can. It's indeed, more time is an indicator of more difficulty, but at the same time it can also mean that it's too easy. So yes, but. And for engagement, well, we don't have any direct evidence for a relation here. And in fact, actually theory and findings from research on text makes it more likely that more time spent equals less engagement. So, that was the talk. Thank you for your attention.
Are there any questions? Engaging or complex or simple?
Thank you. So I'm Leon from the University of Hong Kong. So very interesting presentations. That's what we also need some evidence for our stakeholders. So besides, actually our team, besides producing some MOOC videos, we also produce some videos for on-campus teaching. So those videos will be more related to demonstration, clinical demonstrations, tutorial questions, etc. So with those videos may have a short transcript, but more visual aids. So I would like to know if your proposed framework can be extended to analyze these kind of on-campus teaching videos. Thank you.
Well, let's say the analysis we did cannot, because they only focus on the spoken words. But the framework, more general framework, does have to do with the amount of information that you offer to students and basically the complexity of that information. So that can theoretically be equally visual or auditory, or doesn't really matter how you convey the information. So you would actually expect this effect, and this is also what the wound curve in the beginning showed. You would expect this effect with any type of information. Any type of information can be too complex, too novel, to be comprehensible and to actually engage students. Or, at the other side, not enough.
Hi. Two questions about the analysis. One is your dwelling time variable. Is it normalized for video length?
Yes.
Okay.
Yeah.
And then the second one is a little bit more subtle. So let me explain.
Okay.
Your measure of difficulty, I mean, it's impressive you can explain 22% of variance, but it's going to be a very noisy one. Especially, for example, given the strategy that you use, you're not going to be able to pick differences on the underlying difficulty of the subject matter. I can talk about physics or, I don't know, another non-physics field. Let's not take controversy. With the same amount of words and vocabulary, but the difficulty is going to be fundamentally different. And then you may also expect that more difficult concepts, for example, take relatively more time in a way that is correlated, endogenous. So how do you know, because of this, that your effect of your measure of difficulty on dwelling time is not an artifact to the fact that you cannot take out fully the difficulty, and that therefore you're going to have longer videos when you have more difficult concepts in ways that your measure doesn't capture, and therefore people are also going to spend more time?
So, I hope I can answer this correctly, so you might need to give me some feedback on it again. To the last part, because it's relative, so this is just a short note, the dwelling time is relative to the video length, so actually longer videos or shorter, that doesn't really matter to what we're measuring here. And about the content, actually, well, another note, we do partially have things in there like the frequency, the printed word frequency, and I can imagine that something as you suggest, like the physics, has a very low score on that. But that doesn't mean that indeed we're missing out things in our analysis, and we will keep doing that. So yes, there are some limitations, and of course the MOOCs we used of Leiden University are all more in, what shall we say, the soft skills and the soft courses. So they're not about physics, they're not about very hard equations and that kind of stuff. Maybe get a little bit feedback? Okay, we talk about it during lunch.
Hi, I'm Amy Ogan from Carnegie Mellon University, and we're doing some work with speakers of English as a second language and looking at the ways in which they are interacting with videos, which seem to be very different from native English speakers. And I wonder if you add that variable into your equation, whether you would explain a lot more of the variance.
Good one. Actually, we haven't looked at it, and it might indeed help significantly, because yes, we know that this makes a big difference. And maybe even on that, I would say we have a lot of foreign students anyway following the MOOC, so I would expect that most of them are not native English, which could indeed also really affect the way things show up here.
I'm happy to talk about it.
Cool.
Hi, Ken Kedinger, Carnegie Mellon University. When it seems like you're rightly suggesting that you want to covary some of these other factors to get at better metrics, is the idea that if you were to take the text complexity and maybe also along the lines of Amy's question, some background information on the reader's ability, that then the residual dwell time for an individual on a particular video would be then indicative somehow of whether I'm actually struggling here, are they more engaged or are they more responsive to a challenge? But is that the direction you're going, and how would you interpret that?
Yes, I think there are two notions here. So one, yes, if you would include more covariances like users' characteristics, then you will definitely also explain more of the behavior of a student. So this is quite trivial, but I think the main point is that if you want to actually say something about engagement, you have to ask the student at some point during your study. And that doesn't have to be for all the students and for all the interaction sessions, but without filling in this kind of more subjective aspects, you cannot really draw conclusions from what I draw as the left side of this graph. Does that answer your question?
Hi, Chase Geigel, UAUC. I was curious, so if we don't have evidence yet to suggest that dwelling time, it relates to engagement, do you have any intuition at all at this point about what behavioral proxies we might be able to actually use for measuring engagement, or is that still very open?
I'd say it's more open than we might wish here. And I think the main, as I said it already, the main rule of thumb is that more means better. So more clicks, more whatever, it tends to be better in terms of learning outcomes. That's, I think, the one we know. But in terms of whether that actually makes sense in explaining why it is better or what kind of motivation is behind that, I think we're quite clueless at the moment.
Hi, my name is Tim van der Zee from Leiden University. I'm actually one of the co-authors of this paper, so I don't have a question per se, but I logically, but I did want to comment on one of the other questions. That I've heard some very interesting suggestions on how we can increase our notion of a better understanding of what complexity means, and I think this all contributes to a point that we should, I think, not make those easy assumptions that more clicks or more dwelling times or more whatever means anything by itself. I mean, compared to classroom-based education, what does it mean if a student picks up his or her pen more often? Right? That doesn't have any inherent meaning. It can mean any number of things. So I think the same goes for this type of online research. We have a lot of data, but the data doesn't mean anything by itself. So we should really be looking for those other measures to triangulate the meaning of the data we have through, well, what's presented here, like things like complexity. And the measures we use as well are really, they're not ideal, they're not perfect at all, so they can be improved a lot. So I hope we can all contribute to increasing our understanding of videos and what those data actually mean. Thank you.
And to go from 22% to 24%.
Any other questions from the audience? No? This side? I've been ignoring you. No questions over here? Not yet? Okay, we have one here.
Yeah, I was just tweeting actually a moment ago about it was when I first saw the Coursera, which I think exactly is the point that you were making, the Coursera versus Wikipedia thing. And is it good that Coursera is less complex than Wikipedia? You know, so does this emphasize the point that was being made earlier that MOOCs just teach shallow material, or is it about it being complicated versus complex material? You know, is it that when we speak to a video, we actually use language which covers the same kind of material, but in a more understandable, comprehensible manner? And I think, yeah, we just don't have the data on that, but I'd be really excited when you do have it.
I think both reasons could actually hold here. So indeed, it's very interesting. I would love to get more about that. And in general, I think there is a question we can ask about MOOCs, whether they're primarily oriented at engagement or at learning. So how much do we want to stimulate students?
Well, I have a quick question. I mean, following up on the question over here about other proxies for engagement, considered physiological measures, eye tracking behavior, for example, as a way of getting at that sort of millisecond by millisecond?
Actually, we're having a student working now on testing the algorithms on people reading text with an eye tracker. So, well, that's work in progress.
Well, progress, that's a future work section. We'll see it next year. Very good. Anybody else with a question? Okay, then let's thank our author. Thank you, Frans.